Hello and welcome to ITAC. I am Moses Humphrey.
In the heart of Ondo State and Nigeria, there is a place where innovation thrives and dreams take flight. Welcome to Information Technology's Hub and Synergy. At ITAC, we're more than just a technology hub. We're a nurturing and synergistic community that fosters the creation and support of information technology products and services. Here, people from all walks of life come together to gain digital skills and access top-notch infrastructure, turning their ideas into successful digital ventures. Entrepreneurs find a home at ITAC, where they can transform their ideas into successful digital ventures. With the support of our vibrant community, we strive to establish an ecosystem that nurtures creativity, collaboration, and entrepreneurship, allowing individuals to flourish and make a meaningful, long-lasting difference. At ITAC, we embrace the convergence of technology, creativity, and business, fueling innovation and driving digital transformation. Our commitment to excellence, innovation, and partnership supports organizations and individuals in realizing their vision of making a lasting impact on the digital landscape. Join us at Information Technology Hub and Synergy, where innovation knows no bounds and dreams become reality.
Today, we'll be introducing you to robotics and coding in the classroom. Now, this is an area that has proven to foster problem solving, creativity, and digital skills, making learning more easy and engaging as well. So come along with me as we take you into the world of robotics and coding.
Robotics is the intersection of science, engineering, and technology that produces machines, called robots, that substitute for or replicate human actions. A little bit more common term than robotics is robot. A robot is the product of the robotics field, where programmable machines are built that can assist humans or mimic human actions. Robots were originally built to handle monotonous tasks like building cars on an assembly line, but have since expanded well beyond their initial uses to perform tasks like fighting fires, cleaning homes, and assisting with incredibly intricate surgeries. As technology progresses, so too does the scope of what is considered robotics. In 2005, 90% of all robots could be found assembling cars in automotive factories. These robots consist mainly of mechanical arms, tasked with welding or screwing on certain parts of a car. Today, we're seeing an evolved and expanded definition of robotics that includes the development, creation, and use of bots that explore Earth's harshest conditions. Robots that assist law enforcement, and even robots that assist in almost every facet of healthcare. While the overall world of robotics is expanding, a robot has some consistent characteristics. 1. All robots consist of some sort of mechanical construction. The mechanical aspect of a robot helps it complete tasks in the environment for which it's designed. 2. Robots need electrical components that control and power the machinery. Essentially, an electric current, a battery, for example, is needed to power a large majority of robots. 3. Robots contain at least some level of computer programming. Without a set of code telling it what to do, a robot would just be another piece of simple machinery. Inserting a program into a robot gives it the ability to know when and how to carry out a task. Let's talk about the uses of robots. Robots are largely used to perform various tasks and to make human life easy. They are widely used in manufacturing, assembly and packing, transport, Earth and space exploration, surgery, weaponry, laboratory research, and mass production of consumer and industrial goods.
Writing code is writing a precise set of instructions a computer or device can understand. It's explaining exactly what you want your computer to do at any given moment. Computers need to know exactly how to react to things like the clicking of a mouse or the pushing of a button. And whatever happens ultimately is happening because of lines of code written by a human programmer. Just about anything with a plug or battery uses code. It's keeping our airplanes in the air. It's allowing you to swipe a credit card. And the computer doesn't know what to do in any given situation. It has to be taught everything. So you can think of a computer programmer explaining to a computer what we want it to do as like trying to give someone directions for how to drive somewhere when they don't even know what a car is. So you can see what kind of complications you'd run into. You'd have to not only tell them how to get to where they're going, but you'd also have to give them contingency plans for things like what if there's a traffic jam, or what if a truck breaks down in the turn lane, and you'd even need to explain precisely how the steering wheel or gas pedal works. So that's kind of like a computer programmer writing code for a computer. They have to basically teach it everything every time. To understand that communication and how this process even started, you have to go back to the Industrial Revolution, where the first computer program was invented in 1801 by a guy named Joseph Jacquard. He developed a system of weaving instructions, or code, for his sewing looms that could be stored on cards with holes. And there was a mechanism that would go along the card and try to push a pin through. And so either the pin would go through or it wouldn't. It's binary. It's either it does or it doesn't. It's a 1 or it's a 0. And so if the pin goes through the hole, it would allow a rod attached to it to lift, which lifts the string and lifts the associated thread. And if the pin does not go through a hole, the pin doesn't move and the thread doesn't move. So essentially, the card would hold a preset pattern that is read by the loom and serves as a guide, giving the direction to the threads one at a time. And with this contraption, you could create very fancy pieces of weaving. And this idea of there being recorded information read by a machine was quickly borrowed to be applied to mathematical computation. Charles Babbage invented the analytical engine in 1837, and it was basically a calculating machine. Eventually, transistors are invented, which replace punch cards as a way of transferring data, and nowadays we use computers that have billions and billions of transistors, but still carrying that same basic idea of on and off to carry data. As a way of harnessing these various combinations of transistors, we use code. Computer programmers use different languages, whether it's Python for gaming, Java for desktop applications, or Objective-C for an iPhone app. A computer program is only a text file following those rules, and it's eventually translated into something the computer can understand. Just like the pins on Jacquard's loom, a computer can only understand two things. Think of 1 and 0 as the alphabet of a computer. It's like, if you look at the alphabet of the English language, there's only 26 letters, and by themselves, they're meaningless. But when you combine them into different ways, you get the Great Gatsby, or Romeo and Juliet. In the same way, billions of different combinations of 1s and 0s have the potential to give us Microsoft Word or iTunes. And the process goes like this. On the top level, you have a human writing code for a specific computer language, and after this, the code is translated or compiled into a low-level language by a tool called a compiler, and finally the code is translated into binary or machine language by an assembler. So because we have a way of translating human orders in the form of code into 1s and 0s that a computer can understand, after that it's really just a matter of what you want the computer to do. And it's like being a chef writing a recipe, because both chefs writing recipes and computer programmers writing code both have the ability to create something awesome using the resources and tools available.
Now, this has proven to foster problem solving, creativity, and digital skills, making learning more engaging for students, of course.
As our societies evolve, so do our education systems. But what does the future of education look like? To answer this question and understand how traditional models are evolving, we looked at emerging features that may become the new normal in education systems around the world. What did we see? Traditionally, in education systems, decisions are made by a select group of people, and everyone has a distinct role. Students learn by listening to their teachers, teachers teach, and principals manage the schools. The curriculum is linear and standardized. Academic performance is prioritized, and students are assessed through standardized tests. How is this changing? Education systems embodying the new normal are part of a larger ecosystem where decision-making and responsibilities are shared among a wide group of stakeholders, and students are active participants in their own learning. In these schools, the learning process and student well-being are also valued in addition to academic performance. There is a recognition that students come from different backgrounds and learn in different ways. Learning happens in a non-linear process with different types of assessments used for different purposes. These schools are monitored no longer just to ensure accountability, but also to encourage frequent feedback at all levels to continually improve the education system. The future, by definition, is unpredictable, but by developing responsive education systems, we can help our children adapt to, thrive in, and even shape whatever the future holds.
My child need the best. Every parent approaches tomorrow with this great desire, dreaming about their kids' brighter future. A brighter future in the 21st century using the 19th century curriculum. Do you really think this usual education system based on the past technologies and facts can make your child stand confidently in front of the future jobs? The future job needs creativity, problem solving, innovation, emotional intelligence, and updated technical knowledge. Learning just the building blocks of education like science and mathematics is not enough. For a moment, take yourself to those days when we holded a very simple mobile phones in our hands with which we just made calls and messages. Now, look at the same hands holding a smartphone with a whole new set of features. Maybe it would have taken about 10 years for all mobile phones to get transformed as the smartphones that we have right now. But now, it takes only a weak gap to get a totally revised smartphone with a new feature. Such a drastic change has even affected our existing jobs. You can find robots performing surgeries, manufacturing automobiles, replacing receptionists, in short, almost in all job domains. It's high time to move along with the shifts in the world, and for that, we should layer our existing curriculum with new ideas that can make our children compete with the machines in the future. To make your child the best competitor in the automated world, robotics, a field that can mold your child with building blocks of education as well as with the future technology.
Oh my goodness, was that interesting or what? Oh well, let's now go into the world of technology and look at that technology that the world is talking about this week. Something that you should add to your catalog. All right, come along with me on Tech in View.
To many people, this is what big data looks like. Streams of abstract information. All kinds of data gathered from internal and external sources like CRM systems, customer contact, billing, market research, social media, mobile data, and more. Together, this data must surely be able to deliver value for both the company and the customer through a deeper understanding of customer behavior, brand performance, and market development. At least, this is what big data promises. But in the real world, it's not that simple. How do you go from accumulating the growing amount of abstract and diverse data to gaining insights for making substantial impact? In Creating Value with Big Data Analytics, Peter Verhoef, Edwin Koge, and Natasha Walk introduce a framework that is applicable to any business, not by focusing on the technical, abstract side of big data, but by taking a more practical approach, starting with the business objectives. To begin, it takes certain capabilities to define the right questions and to apply analytics that generate the right answers to these questions. This input is at the heart of the big data value creation model. The first step is to define the right key performance indicators to measure the value to your firm and the value to your customers at 3 levels: market, brand, and customer. Second is to define a data strategy to identify the data you can use to monitor these KPIs. This strategy can be redefined and broadened at any stage. Then, retrieve, merge, and analyze the data as determined. This is where all the effort comes together. The final step is to gain insights and create access via an actionable dashboard. This framework provides any company easy access to valuable insights to make a significant impact on their business.
My name is Aisha Hussein. I am part of the organizer of this event, and we chose this event, we started this event to explain to younger ones that are coming that we don't have the opportunities that they are getting now, so to put them on the right step, for their next career, their career journey, to guide them, to give them, more like past questions.
I want to say a very big thank you to the ITAC. It's such a privilege to be here.
I'm also saying a big thank you to the organizers of this program for them making me part of this beautiful program.
I thank ITAC for putting this together. I thank our school for bringing us here. So I pray that they have more opportunities to do this.
I'm going to tell the ITAC that thank you so much for teaching me and letting me to achieve my career and letting me to know what I'm going to become in life. So that if I become it, I'm going to teach other people. So thank you so much.
I'd like to appreciate the MSSN Yabatech and ITAC because without them, I will never be engaged in this program. And it is an opportunity for me in engaging in this program. So I say a big thank you to ITAC. Thank you very much.
ITAC, I think I think for me, I especially have to thank them because looking at it is an impromptu call to come and sponsor this program, and they came in with full support that we couldn't get elsewhere, and they came in and gave us full support from every angle, and we are grateful to everybody at ITAC, the teams, the media team, the tech team, everybody, the NBC, everybody at ITAC. Thank you very much.
So big shout out to the sponsor, it's our Information Technology Hub and Signature, whereby they actually work in technical education services, software development services, and anything related to tech, they are actually involved in it. So big shout out to them. We really thank them for their support, for them to listen to us and really to sponsor our program. Because without them, some things in this program won't actually work.
Thank ITAC for investing in this event, for making it possible for us to hold all of this. We thank you and pray that we have much more collaboration in the future.
world of technology, applications are born every day. Now, which one is making the world spin this week? Well, let's look at App of the Week. Well, embracing technology in education empowers students with the skills they need for a digital future. Well, that's it on ITAC for today. I am Moses Humphrey. Till I come your way again, ensure you're learning and acquainting yourself with something new. Bye for now.